Hello students, under the topic vector differentiation, we are solving problems under divergence of a vector point function where the question here is to determine the constant a so that the given vector point function is solenoidal. We know that the vector point function is said to be solenoidal if the divergence is equal to 0. That is, if the divergence of the function f is equal to 0, then we say that f vector is solenoidal. So the divergence is given by nebula dot f vector, that is equal to, we know that it is dou by dou x of v1 plus dou by dou y of v2 plus dou by dou z of v3, where this v1 is the ith component, v2 is the jth component, and v3 is the kth component. Now if this divergence value is equal to 0, then the vector is said to be solenoidal. So the f vector is said to be solenoidal if the divergence is 0. So knowing this concept, we have to prove that the given f vector, it is already given that f vector is solenoidal. We have to determine a constant a. If you see, we have a constant a which is an unknown over here. So we have to determine this unknown by using the concept that f vector is solenoidal. So how shall we do that? First we will calculate the divergence of the vector point function f vector. So the divergence nebula dot f vector is equal to dou by dou x of, what is v1? This one, that is x plus 2y, plus dou by dou y of, what is v2? This one, so y minus 2z, plus dou by dou z of, what is v3? It is this, so x plus az. Now since this is solenoidal, nebula dot f vector will be equal to 0, and so this will be equal to 0. So this is what we get. Now what is the partial differentiation of this term with respect to x? 2y will become 0 and the differentiation of x is 1. And here we have 2z which will become 0 and the differentiation of y with respect to y is 1. And here partial differentiation with respect to z. So x will become 0 and the partial differentiation of az is, the partial differentiation of z is 1, and so a into 1, which will be a. So plus a is equal to 0. So from this we get 2 plus a equal to 0, and therefore the value of the unknown a is equal to negative 2. So therefore we have found the constant a to be equal to negative 2 when the given vector f vector is solenoidal. So this is how we have to do. We shall solve some more problems to understand it more better. So now here we have the next question. The question is, find the values of m if the following vectors are solenoidal. They have given some three subdivisions. First subdivision is this. So now we have to prove that this vector point function is solenoidal. We know that if the divergence of the vector point function is equal to 0, then the vector is said to be solenoidal. Now here we have to find the value of m. Actually, where is m over here? Here we have the unknown m to over here. Now we have to find the value of m by using the concept that the given vector is solenoidal. They have given that it is solenoidal. Using that concept, we have to prove that we have to find the value of m. So in order to do that, we know that this vector is solenoidal if the divergence is 0. So divergence is given by dou x of, the first ith component is x plus 2y. You have to add this with dou by dou y of jth component, which is my plus 4z, plus dou by dou z of the kth component, which is 5z plus 6x, and this is equal to 0 since the given vector is solenoidal. So now if we differentiate this with respect to x, we will get 1, and when we differentiate this with respect to y, this will become 0 and we will have m into 1, so plus m, and when we differentiate this partially with respect to z, we get 5, so plus 5 is equal to 0. So from this we get 6 plus m is equal to 0, and therefore we get the value of m to be equal to negative 6. So we have obtained the value of m by using the concept of solenoidal vector. So we will see the next two subdivisions along with this. Now, the second subdivision is this. This is the vector given. We have to prove that this, I mean, we have to find the value of m given that the given vector is solenoidal. So, if it is solenoidal, we know that dou by dou x of this first component, that is 2x plus z, plus dou by dou y of the jth component. So, 4x minus 11y plus 3z, plus dou by dou z of the kth component is 3x plus my. We know that this is equal to 0 since the given vector is a solenoidal vector. And so on differentiation, the differentiation of this will be 2 partially with respect to x, and the differentiation of this partially with respect to y. So x and z will be treated as constants and they become 0. So you will get negative 11, and the differentiation of this partially with respect to z, we have this m, so plus m is equals 0. So from this we get minus 9 plus m is equals 0, and therefore the value of m is equal to 9. So this is the value of m. So here we have the third vector. We know that dou by dou x of x plus 3y plus dou by dou y of y minus 2z plus dou by dou z of x plus mz is equals 0, because the given vector is solenoidal. So on differentiation, the differentiation of this with respect to x is 1. So since partial differentiation, this will become 0, and here also plus 1, and here it is plus m, that's equals 0, and 2 plus m is equals 0, and the value of m is equals minus 2. So we are done with all the three subdivisions. Now here we have the next problem, problem 41. So it is given that the given vector is solenoidal and we have to find the value of a. So we know that since it is solenoidal, dou by dou x of a x square z square plus dou by dou y of x y z square plus dou by dou z of negative x z cube is equals 0. So now partially differentiating this with respect to x, we get 2ax square, and partial differentiation of this with respect to y, we get xz square, because the differentiation of y is 1. Negative, this negative sign I have written, and partial differentiation of this with respect to z. So 3xz square is equal to 0. Now from this we can write 2axz square, and this becomes negative 2xz square is equal 0. Now in these two terms, xz square and xz square is common, and so we can take it common out. So 2a minus 2 gives us xz square is equals 1. So from this we can equate this 2a minus 2 to be equal to 0. So therefore 2a minus 2 is equal 0. So from this we obtain 2a to be equal to 2, and the value of a is equal to 1. So therefore we have obtained the value of a to be equal to 1. We will complete this concept with one more problem. So I hope by now you must be very clear with the concept of finding the unknown when the given vector is solenoidal. So in our next video, we will learn curl of a vector point function, and when do we say that a vector point function is irrotational, and in a similar manner we will also find the unknowns when a given vector is irrotational. So all these we will learn in our upcoming videos. So kindly follow the next video lectures. Thank you.